Hey, we are talking about similar figures part 2, unit 7, lesson 2, 7.2. So this is still geometry, clearly, but we are applying your knowledge of similarity from the last lesson to finding a missing side on similar figures. So before we were saying how the ratios had to be constant. Well, what does that really mean? It means that if you set up a ratio like on this one, the two short sides make an 11 to 15 ratio, okay? So I'm going to put here 11 to 15 because the short side on the small rectangle is 11 inches compared to the short side on the big rectangle, which is 15. Now, we want to set up the other side of the proportion as well, and we want to do it in the same order. So first, we named the 11 on the short side, which means on the second one, we're going to name the 14, the long, on the small rectangle. So that's going to be our 14. And then the long side on the big rectangle, we don't know. That's the one that they have labeled H. So we are going to say H. So 11 on the small to 15 on the big has to have the same ratio as 14 on the small to H on the big. And all we would do here is solve this as a proportion. So 14 times 15 equals 11 times H. The 14 times 15 is 210 equals 11H. Single step multiplication problem. So we're going to divide both sides by 11, and we're going to get 19.09 repeating equals H. Not particularly friendly to work with. You could leave it as that, or you could say that H is approximately 19.1, and then we're going to look over here, and we're going to remember to label it with our units, inches. If it didn't have inches, then we might just say the word units. If you decided, however, that you were going to label yours in a different order, it still might work just fine. So let's say, for example, you wanted to compare the 14 to the H first, and you did 14 over H, and then you did the 11 to 15 second. You'd still be doing 14 times 15 equals 11 times H, and you would still get the same missing side. So now let's look at some triangles. With rectangles, it's pretty easy to be short side versus long side. On the triangles, we have to think about where they are in relation to the rest of the triangle. So for example, we've got what we would sort of consider the two bases here maybe, the 5.7 and the 9.1. You will also notice they are the shortest sides on both triangles. So I might say 5.7 to 9.1, and that's going to be how the green sides create our initial ratio. Now, we are looking for both T and E. So let's first tackle the hypotenuse, all right? So 5.7 compared to 9.1. And then on the hypotenuse, I might say, so 11.2 compares to the missing side T, the one that we don't know. So I've compared the two green sides, which both have measurements, to the hypotenuse, 11.2, and the other hypotenuse, T. Now you'll notice that I'm purposefully picking two sides that have a measure. The same way I did on the rectangle. I started with the two sides that had a measure because that sets up your ratio. So there's a ratio of 5.7 to 9.1. I want to keep that ratio the same and figure out 11.2 and what number would give me the same ratio. So if I do the cross multiplying, right? I'm going to have to do 11.2 times 9.1 equals, and then on the other side, 5.7 times T. So I have to multiply the left side, and I'm going to get 101.92 equals 5.7 T. I'm going to divide both sides by 5.7, and I'm going to get approximately, I do have to round, 17.9. So we're going to say that T is approximately 17.9. I'm going to look back here and see that it is inches. Now, there was a second one on here that is not labeled. So in order to get that one, I'm going to say, if I start with the same two green sides, because those both have a measurement, I can then make my other ratio the other two sides that we're missing. So 5.7 to 9.1 has to be equal to, now 5.7 is on the small triangle, so 9.6 to the missing side, E. And all I did was change the second fraction and keep the first one the same because the first one both had numbers. So I could start with 9.6 times 9.1 equals the other diagonal, 5.7 times E. The 9.6 times 9.1 is going to be 87.36 equals 5.7e, and I will have to divide both sides because that was a multiplication problem, one step. So I'm going to use division on both sides, the same way I use division on both sides here. And I will get 15.3 is approximately E. I had to round my answer. So I'm going to say E is approximately 15.3 and then double check I'm using inches on this one. Not too bad. I often use the highlighters or maybe colored pencils or markers, something to keep my order matching and consistent. Now, last but not least, this one has something a little bit trickier about it, and that's the fact that there is one triangle sort of embedded inside the other triangle. So I am going to use my highlighter to really keep me organized on this one. And the first thing I'm going to do is I'm going to redraw that small inside triangle so that it is no longer inside. So this is E, this is D, this is A. I know this little short side is 2 meters. I know this side over here is 152 centimeters. I'm just copying from this part of the picture and labeling it up here. I'm also going to stick in what appears to be a right angle on both of these because they look like they are corresponding. So let's look. Susie enjoys rock climbing and wants to know if she has enough rope to get up the cliff. She does not know the height of the cliff. Okay, so the height of the cliff over here is the thing she does not know, but has the information given below. Write and solve a proportion to find the distance from the canyon floor to the top of the cliff. All right, so first things first, let's start labeling corresponding sides. This side CB, the cliff, is corresponding to this short side inside the triangle, or on the far right, the vertical side of the small triangle. I also have this bottom of the big triangle corresponding to this bottom of the small triangle. And the most important thing here is to notice that this side of the triangle, this long side, is 2 plus 22, or 24 meters. Even though it is labeled as 2 and 22, the purple is the whole bottom. So I have to add those together. The last kind of funky thing is that this was labeled as 152 centimeters. This one's in meters. This one's in meters. They have to be in the same. So you could convert them all to centimeters or convert them all to meters. Because there's only one here in centimeters, I'm going to go with 1.52 meters instead of 152 centimeters. I moved my decimal point 2 places. And now everything's in meters, and I can set up my proportion to solve for x. So the two that have numbers are the 2 on the small triangle compared to the 24 on the large triangle. And those are the ones that I had colored in purple. So the 2 along the bottom short and the 24 along the bottom large. And that is going to be set equal to 1.52 on the short, and it is in the corresponding location to the x. So 2 to 24, and I wrote 25. I probably said 25. My apologies. 2 to 24 is the same ratio as 1.52 to x. So when I go to cross multiply, 24 times 1.52 has to equal 2 times x. I'm going to get 36.48 equals 2x. All I did was multiply the two numbers that are on the same side together. Divide both sides by 2 because it was a one-step multiplication. 18.24 equals x. So I'm going to say x is 18.24 meters. And that is the cliff. Now, if I go back to the original question, we were looking for the height of the cliff from the canyon floor to the top of the cliff. Susie's climbing rope is 40 meters long. She needs as much going down as going up. Is her rope long enough? So in order to go up, she needs 18.24, and then she needs another 18.24 coming down. So I'm going to need 18.24 going up, 18.24 coming down. I'm going to need 36.48 meters of rope. So if I need 36.48 meters of rope, and it says she has 40 meters, then we could say, yes, she has enough. She has more than the 36.48 needed.